Welcome again to this channel. In this video, we will optimize a machine learning model. We will optimize it um, with a specialized library in Python. This library is H2O. We have many libraries in Python to optimize machine learning models. However, in this video, we will work with this one, H2O. It's a very interesting library because it evaluates by itself many models. For example, it can evaluate a random forest model, extreme gradient boosting model, and more at the same time for one problem. For example, if we want to classify or perform a classification with a machine learning model, we can use H2O library to optimize the model. The first step is to install the library. In this case, we are working with Google Colab. It's a Jupyter notebook. And in this environment, many libraries are already installed, like pandas, like NumPy, like Matplotlib. But H2O is not installed by default. We have to install it, and we can do it with this part of code. Pip install H2O. Let's install it, and we have to wait some seconds. The next step is to load the necessary libraries. We start with libraries for data management and plotting, like pandas, like NumPy, Plotlib, PyPlot, and Seaborn. The next step is to load libraries for data management, like scikit-learn datasets. This is for examples for load data that are already prepared to work with so many models. Also, we need to to load some functions like train test split to split our data into testing and training parts. Then we have to import the H2O library and some functions from it, like H2O AutoML. Then we have to load functions to evaluate the results. We will use, in this case, scikit-learn the model metrics to import accuracy, confusion matrix, and classification reports. Also, we can load some optional functions like partial dependence display and another optional libraries, warnings, and job leave to manage and control the workflow. Okay, let's start with the interesting part, the data preparation. In this video, we will use the famous iris dataset. We can use also more complex data like breast cancer data. However, to introduce you in this world, we can use an easy or very simple data like iris. Remember that we have the columns of or the features that we will use to construct our model, and also we have the target. Okay. And from this data set, we need to create a data frame that we can manage it. And then we have to split the data into the train and testing parts. For that, we should use this function, train test split. We use the data. The data is the pandas data frame, and we can choose here the training proportion, which in this case 75% to training and 25% to evaluate. Let's do it. What happens here? Data set. Okay. we need to load the libraries first, sorry. Okay, it's ready. And if we want to see the data, we can exactly data. Remember, we have 1, 2, 3, 4 columns or 4 features to predict our target. The target is the class in the data, and we can see here iris dot feature names exactly. Okay, it is not target names. Okay, target names Setosa, versicolor, and virginica are equal to the target. So data, the target 0, 1, and 2 are equivalent to these classes. So there are categorized as numbers, but the final classes are Setosa, versicolor, and virginica. Okay, let's start with the models. To use H2O library, we have to initialize the cluster with this function H2O init, and then we have to transform our datasets into H2O frames. What is happening here? Why not just use the pandas data frame? So H2O has functions um, to improve the use of the memory and to take advantage of distributed computing. I mean, to parallel to perform parallelization, and it's very efficient on that. Okay, that's why we need to transform, or that's why we use this function to transform the train and testing dataset into H2O frames. Okay. The next step is to set the target and the feature columns. Here we are only saying that X are equivalent to the features and Y is the target. So, just defining the names of the X columns and the Y column. So train H2O target equals train H2O as factor. We are doing this because remember, we have the classes as numbers, and we have to transform it to factors in order um, to say the model that we are working with classes, not with numbers, right? Okay, let's continue. The next step is to perform the the, the, the the auto optimization of our model with this function H2O AutoML, right? Okay. This parameter, max runtime seconds or max runtime secs, is equivalent to the maximum number of seconds we need or we want to spend doing the optimization. For example, we have we can define 1 hour, 1 minute, or 2 minutes, for example. And then once defined this parameter, we can now perform the optimization. use this x equal x, that are the columns we define here, and y xy. Y equals y, sorry. We are saying the function that the y column is called target, and the other ones, the feature columns, are the names of the columns of the dataset. And then we use the training frame as the, we define this parameter, training frame, as the train H2O dataset that we defined here. Okay, let's let's run the model. Okay, it's starting, and we have to wait until 2 minutes to perform the model to perform the analysis. Okay, it's doing. It's running, and when the model is completed, or when the library, the AutoML, is done, we can evaluate the results. How to do that? With this function, ml.predict. We use the testing dataset, and we store this in the breadth variable, and then we transform it into a data frame. Okay, it's still running. Okay, once the optimization has finished, we can evaluate it. We can check the leaderboard here with the leaderboard method using the AML object that we defined previously. Let's do it. Let's print it. Okay, we can see here the evaluated models by the H2O optimization process. We have here, for example, gradient boosting. We have here also extreme gradient boosting. And our winner, deep learning grid. It's a deep learning algorithm. And the H2O library, the H2O optimization process, decide that this was the best model for our classification problem. And we can see here the mean error per class, also another metrics like log loss function, like root mean square error indicator, and also the mean square error here. And also we need to evaluate the model, of course. Let's do this with this function, accuracy score. This comes from scikit-learn library. And to do this, we need to use the true labels, the true target, and the predicted by the model. To obtain this, press df is the predicted or the predicted labels for the model, and we have to compare it with the real labels here in the true y. Okay, the true y we can extract it from the test H2O frame. We have to transform it into a pandas data frame, and to to flatten the values. So we have to evaluate the accuracy here, and we can print where is the model, or where the library store the best model. Let's run it. And we have here the accuracy of 84%. Of course, we can increase the time that the model used to optimize the algorithm. It will be, of course, so for sure we will obtain a better accuracy with more time. For example, here we can increase to 3,600 seconds to let the model use 1 hour to optimize our prediction. However, for this exercise, we just used 3 minutes. Okay, let's see. Let's test the algorithm with more seconds. Let's say 200 seconds. Run it again. Let's wait some seconds. Okay, let's evaluate the results again. Run this, and the evaluation 97%. It's improved, of course. If we have more complex data, of course, we need to increase the time of seconds. So we have to increase the seconds the model or the algorithm takes to perform the optimization. Okay, let's continue. We can also plot the confusion matrix. We can have also a classification report, and we can see it in a very useful plot. To do this, we need to create the confusion matrix with this function. We need the true values and the predicted values again. And also to perform the classification report, we need all again the true values and the predicted values here. And then we have, or we can save the model, and then we need to, or if we want to plot the results, we can do it with with matplotlib and seaborn. With this function, heatmap, we need the confusion matrix, and also we need the labels from the target names, and also for the predicted values and the real values. Okay, and we can also print the best hyperparameters obtained by the model. Let's do it. And of course, we need to finish our model with H2O shutdown. And let's see our classification report. We have here the precision, the recall F1 score, and support for the three classes. Remember that we have the classes as numbers, but are equivalent to the names or the flowers in the iris dataset. We have also the summary here, the accuracy, the macro average, the weighted average, and we have here the 90% we observed previously, and we have here the confusion matrix. Let's evaluate it. We have here in the y-x the real values, and in the x-axis the predicted ones. Okay, so here we need to have all the values in the in this part, in the diagonal. That means all the setosa classes were predicted as setosa. Also, we need all versicolor classes predicted as versicolor, and the virginica as virginica. And then we have one error here, a virginica flower or observation classified as versicolor. We have 11 correctly classified, and then we have 10 virginica classified as virginica. We have 0 virginica columns classified as setosa, and also all setosa rows are classified as setosa rows. And we have here, of course, a very simple approach to evaluate the model. We can do more things, like, for example, increase the number of or increase the time to optimize the model. We can also include more terms like or more parameters to perform, for example, cross-validation, to modify the cross-validation algorithm. For example, we can perform K cross-validation or leave one out cross-validation, and so on. Okay, that's it for now. And also, if you want to go deeper in this world of optimization, you can go to my Udemy courses. I let you in the description the links for that. One specialized course in optimization of machine learning algorithms, and also the main page of my profile in Udemy, that you can find more courses there. Okay, see you again, and it's a pleasure for me to share this with you. Thank you.